This section we're going to talk about graphing rational functions. In fact, we're going to graph rational functions. First obvious question is, what is a rational function? A rational function is in the form, or can be put into the form of one polynomial over another polynomial. P of x over q of x, where p and q are polynomials, where p of x and q of x are polynomials. Next definition. A vertical asymptote. Where does it happen? A vertical asymptote is at a x value that makes the numerator equal to 0, but the denominator is not 0. So an x value, the vertical asymptote is at an x value that makes the numerator 0, but it makes the denominator 0 but not the numerator. It makes the denominator equal to 0, but I'll change that letter, but the numerator is not 0. It makes the denominator 0 but not the numerator. Whatever that x value is that makes the denominator 0 but not the numerator, you have a vertical asymptote there. Now we're going to talk about horizontal asymptotes. That one's a little bit harder. Horizontal asymptotes. If the degree of p of x is greater than the degree of q of x plus 1, then there is no horizontal asymptote. Then there is no horizontal asymptote. The degree of the numerator is just too large. Number 2. If the degree of p of x is less than the degree of q of x, what happens then? Then y equals 0 is the horizontal asymptote. What if they're equal? If the degree of p of x is the same as the degree of q of x, then y is equal to a over b is the horizontal asymptote, where a and b are the coefficients of the leading terms, respectively. Why don't we look at an example here? If y is equal to 3x to the third minus 4x squared plus 9 over negative 5x to the third plus 4x minus 11, since the degrees are the same, they're both 3, you just divide the numbers in front and you have the horizontal asymptote. We have one more. What if the degree of p of x is not greater than the degree of q of x plus 1, but in fact they're equal? Then what you do is long division. Then divide. So, for example, if p of x over q of x, if the degree of the bottom is 1 larger, what you are going to get is something in the form of a plus b plus the remainder, which gets divided by q of x. Y is equal to ax plus b is the horizontal asymptote. If you have, I don't know, 2x cubed plus 4 in the bottom, and the top is 1 more, 3x to the 4th plus 11. If you did this division, maybe you'll get 13x plus 5 plus 2 over 2x cubed plus 4. I guarantee you it will be linear plus a remainder. Okay, this here would be the horizontal asymptote. I'm not going to spend the time to do the division. Just make believe that you did the division and you got 13x plus 5. I guarantee you you'll get ax. And the reason is, if you have x to the 7 plus lower terms divided by x to the 6 plus lower terms, when you do x to the 6 plus the lower terms into x to the 7 plus lower terms, x to the 6 goes into x to the 7's x times. So you're going to get x to the 7 plus x times lower terms. Okay, and then the most you're going to get is an x to the 6th. You might get 3x to the 6th plus lower terms. And you multiply that by 3 to kill off the 3x to the 6th. Now, the lower terms are all less than 6. So you're just going to have lower terms less than x to the 6th. That's going to be the remainder. I don't care what the remainder is. That's going to be the horizontal asymptote. Now, let us look at this step. If you have y is equal to 7x minus 1 over x plus 2, a vertical asymptote is going to happen at 2. Because when x is 2, the bottom is 0 and the top is not. So I want to know what this is approximately equal to if x is a little bit more than 2. Well, the numerator will be close to 13. 7 times a little bit more than 2 will be a little bit more than 14. You take away 1, you'll be a little bit more than 13. The bottom is going to be really close to 0. But if you have a little bit more than 2, just a little bit more than 2, and you take away 2, you're going to be just a little positive. And a positive over positive is positive, and 13 divided by very close to 0 is infinity. Now, what happens on the other side of x equals 2? What is this approximately equal to if x is just a little bit less than 2? Well, 7 times around 2, whether more than 2 or less than 2, is around 14. And you take away 1, you're around 13. Whether you're a little bit more than 13 or a little bit less than 13 doesn't matter. In the bottom it does. Because if you're a little bit less than 2, if you have less than $2 in the bank, and you convince them to let you take out 2, you'll be really close to 0, but you'll be negative. If you have 1.99999 and you take away 2, this will be less than 0, and it'll be close to 0. A positive over a negative is a negative, and 13 divided by close to 0. If you take 13 and you divide it by a number close to 0, like negative 1 over this number. That number in the bracket is very, very close to 0, and it's negative. But this becomes 13 times, no promises I'm going to put the same number of zeros. This answer is negative, and it's very large. Again, no promises, the same number of zeros. This is going towards negative infinity. Whenever the numerator is not 0 or near 0, and the denominator is really, really close to 0, you'll either be getting close to positive infinity or negative infinity. Every time you have a vertical asymptote, if you're a little bit to the right of the vertical asymptote or a little bit to the left of the vertical asymptote, you'll get one of those answers. They can both be the same. In theory, depending upon the problem, I could have gotten positive infinity for both of them. I could have gotten negative infinity for both of them. But I guarantee you it'll be one of those two for each one. Okay, that's a little bit abstract, but that's what's going on. Now, we're going to have to know how to graph these things. Suppose that you have a vertical asymptote here. You have a vertical asymptote here. You have a vertical asymptote here. And you have another one here. And if we need any more, we'll get to that. And you have a horizontal asymptote. Now, to the left of this x value, you can be negative. And to the right, you can be positive. You know what? Look, okay. And maybe here to the left, you're negative. And to the right, you're also negative. And maybe to the left of this x value, you're positive. And to the right of this one, you're negative, and to the left of this one, you're negative. And I think I need at least one more vertical asymptote. Yeah, maybe two more. To the right of this one, you're here. And to the left of this one, you're here. And to the right of this one, you're up here. And to the left, you're also up here. Let's talk about the middle ones, not their two left ones. To the left of the leftmost vertical asymptote and to the right of the rightmost asymptote. Let's just talk about what's happening in here. You're going from very high to very low. It always goes like that. Okay, if you're going from low to high, it always goes like this. If you're going from low to low, it goes like this. No guarantee how high up we go. We could have just gone like that, but it's that nice, simple U shape. When you study calculus, you'll learn how high up to go. But in pre-calc, it goes like this. And, oh, okay, so I already have this one. I didn't need this one, but it goes like that. Now, these two are both high, so they go like that. And again, no promising how low they go. Now, for the left. Let me scroll up a little bit. Now, to the left. If, when x is very negatively large, you're down here, the graph will go like this. And again, it is possible, but you need calculus to know this. It is possible it could have gone up and then come down. Your teacher can't expect you to know that. Okay? Your teacher should accept what I have in yellow, even if, quote, it's wrong. Your teacher, in all fairness, should make sure that the green that I just erased is not the way it should look. Okay, now towards the right. If you're up here, and again, here's the horizontal asymptote, you go like this. If you were down here, you would just go up like that. If you were up here, you would go like that. You need to know this. You need to know this. Again, let's just talk about the middle. If you have one high and then one low, goes that way. If this is the high one and this is the low one, it goes like this. If they're both high, it goes like this. I can't tell you how low it goes. It could have gone a lot lower. No promises. If they're both low, I'm giving you every combination. If they're both low, it goes like that. Okay. If it turns out that this yellow line was the horizontal asymptote and you're up here, it goes like this. If you were down here, it would go like that. Up here, at the end, it will go like this. Down here, it would go like that. You have to know this. Now, that's when you have a horizontal asymptote. What if you have an oblique asymptote? So oblique only talks about what happens at the end. Maybe this is your oblique asymptote. So in between two, if the two are vertical asymptotes, if they're both up here, you just come down. If they're both down here, you just go like this. If one's up here and one's down here, you just do like that. If one's down here and one's up here, let me draw a little higher. You just, you just do that. Get closer and closer to the dotted line. That oblique asymptote only comes into play when x is either positively large or negatively large. If you were down here, you have to go like that. At the top, at the right. If to the right you were up here, then you go like this. You have to get closer and closer to the oblique asymptote and to the vertical asymptote. If you happen to be up here, well, then you're just going to come like this. You're going to get closer and closer to that horizontal line. If you oblique asymptote. If you were down here, you would get closer and closer that way. Watch this video, this portion of the video 50 times if you need to. The bottom line is you need to learn how to graph those what happens in between the vertical asymptotes. Okay, so now we'll practice some graphs. Suppose you were asked to graph this. First thing I would do is work on vertical asymptotes. I guess you can work on horizontals if you like first. You have a vertical asymptote at an x value or x values that makes the denominator 0 but doesn't make the top 0. Well, this bottom is 0 when x is 1 and when x is negative 1. And it doesn't make the top 0. So those are the vertical asymptotes. I want to know what is y equal to, well, let's just write it this way. I want to know what happens on each side of the vertical asymptote. If x is a little bit less than 1, what happens? Less than negative 1. If x is a little bit more than negative 1, that spoke about that one. And what happens when x is a little bit less than 1? And when x is a little bit more than 1. X is a little bit more than 1. What does y equal? And I'll give you a hint. It's a big hint. So these are going to be infinity or negative infinity. When x is anywhere near negative 1, the numerator is close to 3. This is the same as 4 plus x. 4 minus 1 is close to 3. Negative 1 plus 4 is 3. Now what happens to the bottom? Well, come on. Here's negative 1. If you're a little bit to the left of negative 1, if you're right here, and you get squared, keep in mind, that's the same as squaring that number right there. It's going to be more than 1. Just a little bit more than 1. Now this number might be negative 1.001. But you know what? When you square that, it's the same as squaring this. You're going to get a little bit more than 1. And then when you take away 1, you're going to be positive. And a non-zero number divided by close to 0 is infinity. The top number is positive, the bottom number is positive, positive infinity. What if x is a little bit more than negative 1? Here's negative 1, that's what x is. 0.999. Well, if you square a number, negative 0.999, when you square that, it's going to be a little bit less than 1. I mean, it's the same as squaring 0.999. It's going to be a little bit less than 1. X squared will be a little bit less than 1. When you take away 1, it'll be negative and very close to 0. A positive over a negative is negative, and 3 divided by near infinity is, but near 0 is infinity. So we now know what happens a little bit to the right of negative 1. Now let's talk about what happens at 1. if you're a little bit less than 1, like 0.999 forever, and you get squared, you're going to be a little bit less than 1. That is, the bottom is going to be a little bit less than 1. And then when you take away 1, it's going to be negative. It's going to be a little bit less than 0. And the numerator is always going to be around 5. If x is around 1, the numerator is going to be around 5. Positive 5. Positive divided by negative is negative. 5 divided by close to 0 is, in this case, negative infinity. If x is a little bit more than 1 and you square it, it's going to be a little bit more than 1. And then when you take away 1, x squared minus 1 is going to be really close to 0, but positive. Positive over positive is positive, infinity. That is what you need to do for the vertical asymptotes. Now, for the horizontal asymptote. We want to know what happens when x goes to infinity. Well, as I told you, if the degree of the top is smaller than the degree of the bottom, then the horizontal asymptote is 0. That was up here, the Bible, for horizontal asymptotes. If the degree of the top is smaller, if the degree of p, the numerator, is less than the degree of the bottom, then y equals 0 is the horizontal asymptote. You need to know the rules to play the game. And let us also find the y-intercept. When x is 0, what is y equal? And the answer is negative 4. Because when x is 0, 0 plus 4 is 4, and 0 squared minus 1 is negative 1. So we found the y-intercept is at negative 4. Now, let's draw what we have. The key thing is this piece and the horizontal asymptote and the y-intercept. So, the horizontal asymptote is along here. Coincidentally, they're x-axis. You have vertical asymptotes at 1 and negative 1. This one tells me, so let me draw them. 1, negative 1. If you're the first one, 1, 2, 3, and 4. The first one says, if you're a little bit less than negative 1, y is at positive infinity. A little bit less than negative 1, go up to infinity. Number 2 says, if you're a little bit more than negative 1, the y value is at negative infinity. Number 3 says, if x is a little bit less than 1, you're at negative infinity. And the next one says, if x is a little bit more than 1, you're at positive infinity. So the middle, and it crosses at negative 4. The middle one, since we're going from low to low, and generally it hits the max or the min right in the middle of the vertical asymptotes. Smack in the middle of negative 1 and 1 is 0. And I know when x is 0, I cross at negative 4. we have that. And when x, the horizontal asymptote is the x-axis. That is, when x is large, I go like this, and I go like this. There is my graph. See if I can move all of this. Oops. Okay. So when x is very, very large, I get closer and closer to my horizontal asymptote. There's the graph. Again, because -1 and 1, the midpoint was 0, I knew that the highest point is going to be on this line. And coincidentally, it was where x was 0 and I knew y was -4. Everywhere on this line, x is 0. I know it is because if I look to the x-axis, if I take this point and I look down to the x-axis, 0. This point when I look down, I see 0. This point when I look up, I see 0. I look up and I see 0. Here's your graph. Let us try another one. Suppose you have x cubed plus x squared minus 5x plus 6. You want to graph this. First thing I would do, should have done it in the last problem, but I want to factor the denominator. This tells me pretty clearly that vertical asymptotes are at x equals 3 and x equals 2. Why? Because 3 and 2 make the bottom 0, but doesn't make the top 0. Okay, so now we want to talk about what happens at 3. If you're a little bit more than 3, you're a little bit less than 3. What is the y value? Y is equal to. Y is equal to. Well, when x is anywhere near 3, the numerator is about 27. Okay, now when x is a little bit more than 3, this number is going to be around 1. That's important. That number is going to be around 1. It could have been around -1, and that would have changed things. When x is anywhere near 3, this is around 1. But when x is near 3, this is 0. More than 0 or less than 0? If you're more than 3, remember, if you're at 3 and you take away 3, you get to 0. Well, if you're a little bit more than 3 and you take away 3, you'll be positive. Okay? You'll be a little bit positive. It'll be 0 positive times 1. If you're a little bit less than 3 and you take away 3, you're going to be negative. So 27 over 1 is positive 27. It's positive. Over 0 positive. That fraction is positive infinity. 27 over 1 is 27. Positive divided by a negative number. This is going to be negative infinity. Now, we're going to do the same thing like we just did at 3. We're going to do it at 2 now. If x is a little bit more than 2, what is y equal? And if x is a little bit less than 2, what is y equal? Well, if x is near 2, the numerator is going to be near 8. And if x is anywhere near 2, 2 minus 3 is going to be near 1. The problem is, if x is near 2, we get 0. We need to decide if it's more than 0. We get close to 0. Is it going to be more than 0 or less than 0? If you have more than 2, so you have 2.001, and you take away 2, you'll have something left. This is negative 8 over 0 plus. That's negative infinity. If you have a little bit less than 2, if you have 1.99, if you have $1.99 and you want to take away $2, you want to buy something for $2, you can't because you'll be negative. So we have negative 8 over 0 negative, which is positive infinity. Now let us work on the horizontal asymptote. Since the degree of the top is 1 more than the bottom, our Bible above, the Bible up here for horizontal asymptotes, they tell us to do long division. It says do long division. Okay, if the degree of the top is 1 more than the degree of the bottom, then divide and keep the line. You'll see what I mean when I say keep the line. When you divide, you're going to have a line plus a remainder. So let us do this division. How many times does x squared minus 5x plus 6 go into x cubed? Well, it goes in x times. X times that will be x cubed minus 5x squared plus 6x. And when we subtract, by design that cancels, and we have 5x squared minus 6x. And x squared goes into 5x squared 5 times. Multiply 5 times that, you get 5x squared minus 25x plus 30. To be honest, you can stop there. That's your vertical asymptote. Because when you subtract, what you're going to be left with is the remainder. And the horizontal asymptote is everything but the remainder. It's x plus 5. So y equals x plus 5 equals the horizontal asymptote. That means when x is positively large or negatively large, you're going to get closer and closer to this line. Okay. So, and when x is 0, you get back 0. Because the top is 0 and the bottom is 6. Y is 6. Sorry. Y is also 0. Okay. So let us graph what we have. We have a vertical asymptote at 2 and at 3. And if you're a little bit more than 3, it's positive infinity. If you're a little bit less than 3, you're at negative infinity, way down here. If you're a little bit more than 2, you're at negative infinity. That's down here. If you're a little bit less than 2, you are at positive infinity. And let's not forget, we have to cross here. 0, 0. Now, the horizontal asymptote is y equals x plus 5. That means it intersects the y-axis at 5, and the slope is 1. It goes like this. I'm just going to draw these lines a little bit higher, put the dot in the same place. Alright. I like to do in between vertical asymptotes first. That is, in between 2 and 3. Goes like that. You can actually plug in the number in between and figure out how high up it goes. You actually can do that. Okay, now to the right, we're way up here, and you need to get closer to the blue line. So it goes like this. And you're way up here, and you need to get closer to the blue line. I want to make sure something's right. 27 and 1. Okay. So you are way up here, and you have to cross here and get closer to the blue line. So I guess it goes like that. Maybe if I didn't find the y-intercept, I probably would have just gone like this. But when x is 0, y is 0. You have to cross the origin. There is your graph there. Let us try one more. Suppose you were asked to graph y is equal to x squared minus x plus 6 all over x squared minus 5x minus 6. Well, if you factor the numerator, you get x minus 3 times x plus 2 plus negative 3 and positive 2. Do not, they add up to, okay, so I guess I want this to be minus 6. The two numbers I wrote down multiply out to negative 6 and add up to negative 1. And in the bottom, I have x minus 3 times x minus 2. I guess that should be plus 6. Oh boy. These two numbers multiply out to positive 6 and they add up to negative 5. Now, if x is not 3, we have x plus 2 over x minus 2. This is what I want to graph, except when x is 3, when x is 3, we get 5 over 1, which is 5. So I am going to remove 3, 5. I'm going to graph this, but I'm going to remove 3, 5. Okay. Vertical asymptote is at x equals 2, because it makes the bottom 0, but not the top. And that's the only one. If x is a little bit less than 2, the numerator is going to be 4, close to 4. And if you're less than 2, and you take away 2, you'll be negative. A positive over a negative is negative, and when you're dividing there's 0, you get plus or minus infinity. In our case, minus infinity. X is a little bit more than 2. The numerator is still close to 4, and x minus 2 in the bottom, if you have more than 2, and you take away 2, you'll be positive. Positive infinity. Now, the horizontal asymptote is going to be y equals 1, because if the degree of the top and the bottom are the same, you are instructed to divide the leading coefficients. 1 over 1 is 1. And while we're at it, when x equals 0, y is, this will be negative 6, this will be positive 6. You divide, you get negative 1. Okay. So, the horizontal is at 1. That's the horizontal asymptote. And then you have a vertical asymptote only at 2. And a vertical asymptote only where x is 2. If you're a little bit to the left of 2, that is less than 2, you're at negative infinity. If you're a little bit more than 2, to the right of 2, you are at positive infinity. Well, there's no middle because I don't have 2 vertical asymptotes. So this one goes like this, almost, and 0, negative 1. So we need to cross at negative 1. So it goes like this. The only exception is when x is 3, even though my scale doesn't look at it, that's going to be 5. We need to remove that point. We just need to remove that point. And there's your graph. Do tons of these. They're not bad. They're not bad. Okay, that completes this video. Thank you.